OpenAL is a cross-platform audio application programming interface. It is designed for efficient rendering of multi-channel three-dimensional positional audio. Its API style and conventions deliberately resemble those of OpenGL. Early versions of the framework were open-source software, but the later revisions are proprietary. OpenAL is an environmental 3D audio library that aims to provide an open replacement for proprietary 3D audio systems such as EAX and A3D. OpenAL can add realism to a game by simulating attenuation, the Doppler effect, and material densities. History: OpenAL was originally developed in 2000 by Lockheed Software to help them in their business of porting Windows games to Linux. After the demise of Lockheed, the project was maintained for a time by the free software open-source community, and implemented on NVIDIA sound cards and motherboards. It is now hosted by Creative Technology with ongoing support from Apple, Blue Ripple Sound, and free software, open-source enthusiasts. While the OpenAL Charter says that there will be an architecture review board modeled on the OpenGL ARB, no such organization has ever been formed, and the OpenAL specification is generally handled and discussed via email on its public mailing list. Since 1.1, the implementation by Creative has turned proprietary, with the last releases in free licenses still accessible through the project's Subversion source code repository. However, OpenAL Soft is a widely used open-source alternative. API structure and functionality: the general functionality of OpenAL is encoded in source objects, audio buffers and a single listener. A source object contains a pointer to a buffer, the velocity, position and direction of the sound, and the intensity of the sound. The listener object contains the velocity, position and direction of the listener, and the general gain applied to all sound. Buffers contain audio data in PCM format, either 8 or 16-bit. In either monaural or stereo format. The rendering engine performs all necessary calculations as far as distance attenuation, Doppler effect, etc. The net result of all of this for the end user is that in a properly written OpenAL application, sounds behave quite naturally as the user moves through the three-dimensional space of the virtual world. From a programmer's perspective, very little additional work is required to make this happen in an existing OpenGL-based 3D graphical application. Unlike the OpenGL specification, the OpenAL specification includes two subsections of the API, the core consisting of the actual OpenAL function calls, and the ALC API, which is used to manage rendering contexts, resource usage and locking in a cross-platform manner. There is also an ALUT library that provides higher-level convenience functions exactly analogous to OpenGL's GLUT. In order to provide additional functionality in the future, OpenAL utilizes an extension mechanism. Individual vendors are thereby able to include their own extensions into distributions of OpenAL, commonly for the purpose of exposing additional functionality on their proprietary hardware. Extensions can be promoted to ARB status, indicating a standard extension which will be maintained for backwards compatibility. ARB extensions have the prospect of being added to the core API after a period of time. For advanced digital signal processing and hardware-accelerated sound effects, the EFX or environmental audio extensions can be used. Limitations: the single listener model in OpenAL is tailored to a single human user and is not fit for artificial intelligence or robotic simulations or multiple human participants as in collaborative musical performances. In these cases, a multiple listener model is required. OpenAL also fails to take into account sound propagation delays. The distance to a sound source only translates into an amplitude effect and not a delay. Hence OpenAL cannot be used for time difference of arrival calculations unless that functionality is added in separately. Supported platforms: the API is available on the following platforms: operating systems, Android, Amiga OS 3X, Bada, BlackBerry 10, BlackBerry Playbook, BSD, iOS, IRIX, Linux, Mac OS 8, Mac OS 9 and Mac OS X. Microsoft Windows API, MorphOS, OpenBSD, Solaris, QNX, AROS, gaming devices, GameCube, PlayStation 2, PlayStation 3, XBOX, Xbox 360, Wii, PlayStation Portable, applications, games. According to Creative Labs, the following video games use OpenAL. According to Beamdog, the following video games use OpenAL: Baldur's Gate, Enhanced Edition. Other applications: Blender, 3D modeling and rendering tool uses OpenAL for its built-in game engine. 3D Mark 06, gamers benchmarking tool, Dolphin, GammaCube and Wii emulator. Vanda Engine, uses OpenAL 1.1 to simulate 2D and 3D sounds. Implementations: OpenAL SI, the OpenAL sample implementation is the original implementation, from Lockheed, and is not currently maintained. OpenAL Soft is an LGPL licensed, cross-platform, software implementation. The library is meant as a compatible update replacement to the deprecated OpenAL sample implementation, as well as a free alternative to the now proprietary OpenAL. OpenAL Soft supports mono, stereo, 4-channel, 5.1, 6.1, and 7.1 output. EonWave OpenAL is an LGPL-licensed OpenAL emulation layer that takes advantage of the hardware acceleration provided by the non-free but low-cost EonWave 4D audio library for Linux and Windows made by ADAL and BV. The author claims that EonWave OpenAL implementation renders 3D audio 5 to 7 times faster than either OpenAL SI or OpenAL Soft under the same conditions. By using the EonWave library, this implementation supports HRTF as well as spatialized surround sound for up to 8 speakers. Rapture 3D OpenAL driver. The Rapture 3D OpenAL driver is a non-free, commercial, Windows-only, software implementation made by Blue Ripple Sound. The library is intended as a high-performance drop-in replacement for other implementations. It features 32-bit floating-point audio path, high-quality sample rate conversion, high-quality effects and filters, directional sound sources, support for multi-channel sound sources. The only limit on the number of sources or effects is CPU power, can render hundreds of sound sources and multiple effects on relatively old hardware. Higher-order ambisonics bus running at up to 4th order. See also: OpenCL, OpenML, OpenMaxAL, FMOD, Java OpenAL, IARA Clang, Lightweight Java Game Library. References. External links: OpenAL Soft, EonWave OpenAL, DevMaster.net OpenAL Tutorials, Rapture 3D Advanced OpenAL 1.1 Driver.